Hey, good morning, everybody. Today we're going to be spending a bit of time reviewing straight line graphs. Straight line graphs is a very essential part of the AISL course. So I just thought I would like to make a quick video just to review some of these concepts on straight line graphs. And if you think that you have always been struggling with the basic concepts, so please make sure you use a little of your time to review this video. I'll keep the video short to cover some of the essential concepts, and so let's get down to business. Okay, the first question, we're going to be looking at sketching of a line. Now I do know that the use of the GDC is obviously possible in the AI course, but we will look at this. I'll review this concept so that it kind of makes a little more sense. I think we should not always be too reliant on the calculator. So I'll show you both ways. Now, sketching of the line y equal to 3x minus 5. Now let's talk about the basic concepts that we know about sketching of a line. So we do know that y equal to mx plus c. This is something you probably have seen for a long time, but let's just review this really quickly. Now we do know that m is the gradient, while c is the y-intercept. So if I'm going to sketch this graph, I'll put the y-axis on the vertical axis and the x on the horizontal axis. Now we do know that the y-intercept is basically the number, or basically where the line cuts the y-axis. So basically the first point that you could plot would be at -5 on the y-axis. Now we do know that the gradient is 3. Now firstly, if this is a positive gradient, we know that this line going in this direction is where the gradient is a positive gradient. Okay, and since the question is only asking for a sketch, as long as we are able to draw the line in the correct direction, having the correct y-intercept, that should suffice. Okay, so I'm just going to draw a line that looks something like this, and that should give you the sketch of the line. Now, but if you want the sketch to be a little more precise, okay, we have the y-intercept, but we could also have something what we call at this point, which is the x-intercept. Now, if you want to find the x-intercept, we could obviously know that at this point, the y-coordinate is always going to be 0. And there is obviously a number that's going to be associated with the x-intercept. And that's the number we want to find. But if we want to find this, we can always substitute 0 into the equation. So you're going to get something like this, which is 3x minus 5 equal to 0. Then I'm going to get 3x equal to 5. And if I solve for x, I'm going to get 5 over 3. So which means at this point, this number is just going to be 5 over 3. And that will give us a really good sketch. Okay, now even though it's a sketch, it should show the essential points on the straight line graph. Okay, now of course you could also find this x-intercept onto the GDC. So on the GDC, I'll show you how this works. If you go onto the calculator, okay, now if I go to step plot and I put 3x minus 5 and I graph it, and if you want to find where the x-intercept is, what you need to do is go to second trace, go to something called 0, press enter, and of course they will ask for the left bound. Okay, just make sure the left bound is somewhere to the left of the x-intercept. I'll press enter, I'll move the right bound maybe somewhere to the right of the, okay, I'll press enter, and you should get the value to be 1.666667, which is the equivalence of 5/3. Okay, so that's how it works on the GDC. Okay, now let's get back to business. Oops. Okay, let's get back to where we came from. Oh no, I don't even know where I put my file now. Okay, I'll just try to open this up again. Oops. You know what, I'm just gonna open up in the PDF. I think that's just probably gonna save more time as well. We're just using a different software earlier to open the file, but I'll just use Acrobat. Probably save us some time. Okay. Alright, so let's get back to the second question. And it says find the equation of the line that goes through the points 1, 1, and 4, 13. Okay, now so before we do that, let's talk about the concepts needed for this question. Okay, now when we know that the equation of a line, I'll just make this a little thinner, y equal to mx plus c. Now that's basically the essential equation that you need to know for all straight line graph. Okay, this is usually what we call the gradient intercept form. Okay, because obviously you could see the gradient, which is m, and you could see the y-intercept, which just happens to be c as well. So if we do y equal to mx plus c, what we could do is we could find the gradient first, which is m. And the formula for gradient, as you probably would have known several years ago, which obviously has been taught, is basically just y2 minus y1 over x2 minus x1. Now you could call the first point to be x1, y1, and you could call the next point to be x2, y2, okay? And if you want to switch the order, that's fine, as long as you're being consistent with your notations as well. So I'm just going to put the values into the formula. So you're going to get something like 13 minus 1 over 4 minus 1. Okay, so I really encourage you to put x1, y1 onto the points, so that it's much easier for you to apply the formula. So you're going to get 12 divided by 3, and that gives me 4. Now, having said this, we can actually write the equation, which is 4x plus c. So we replace the m with 4. But you probably realize that this number, which is c, does not have a number. And all we need to do now is to substitute any of the points, which is either 1, 1 or 4, 13, into the equation. So we could choose either one. But in this case, I'm just going to choose 1, 1 because the numbers are small. But of course, if you prefer to use 4, 13, by all means go ahead. Now, I'm going to substitute x equal to 1 and y equal to 1 into the equation. Okay, so it will look something like this. You're going to get 4, 1 equal to 4 times 1 plus c. So I'm just going to solve this equation, which is 1 equal to 4 plus c. And of course, we can find out c to be 1 subtract 4, which gives me negative 3. So therefore, my equation would just be y equal to 4x minus 3. And that should give you the equation of the line. Now, let's say if you have forgotten how to find the equation of a straight line graph, which I hope not, there's always an emergency function that you could always use on the GDC. Okay, I'll show you how this works. Now, since we want an equation of a line, alright, a straight line graph, we can also do this on the GDC. Now, if we go to the GDC, what I need you to do is, if you go to stat, go to edit. Let me just remove all these points first. So stat, edit. Alright, I'm just going to delete all these points. Okay, now then what we're going to do is we're going to put all these points that I just mentioned onto this little spreadsheet here. Okay, so I'm going to have 1, and so this 1, then I'll have this to be 4, and I'll put 13 here. Okay, and what I want to do is I'm going to go to stat again, then I'm going to count. I'm going to choose this function, which is linear regression. Now we have done linear regression. Basically what it does is that it creates the line of best fit given the points, and in this case we only have 2 points, so technically you should form a line with 2 points. So what the calculator does is that it tries to find you the equation of the line, but what it shows on the calculator will look something like this. So if I go to linear regression, make sure X this is L1, Y this is L2 is because we just put the data on L1 and L2. Okay, just leave frequency list alone, and I'll just press enter all the way, and you realize that your A is 4 and your B is -3. Now your A in this case is the gradient, while the B is the y-intercept, which is -3. Now let's go back to what we have here earlier. You realize the gradient is also 4 and the y-intercept is -3, but make sure you write the equation as y equal to mx plus c. Okay, so you can't just tell me that the gradient is 4, the y-intercept is -3. You have to write it in the proper equation form. So that's always an emergency way. If you are using the TI-84, that should be the way to go about doing it. But if you use any other forms of calculators, you should also be able to produce the same work using linear regression on your calculator. Okay, all right, let's move on to question 3, which is finding the equation of the line. Now since we got a graph here and we do know that the y-intercept is 1, so y-intercept is 1. Now then of course we can find the gradient from a straight line graph by choosing any 2 points on the graph. Okay, so I'm just going to show you maybe with a different color. I could choose this point. I could also choose this point if I want to. So any 2 points that you could identify the coordinates easily. Okay, so having said this, if you look at this little part here, okay, now what I want to do is I want to find out what is this value here and what is this value here. Okay, but before we do that, we can always identify the coordinates of these points. Now this would be written as 2, 2, and this would be written as 4, 5. Remember, the x comes before y. Okay, and if we have this, we can apply the formula again, which is y2 minus y1 over x2 minus x1. Now this is x1, this is y1, this is x2, this is y2. Okay, then we just put the numbers into the formula. So you're going to get 5 minus 2 divided by 4 minus 2. So that should give me 3/2. Alright, of course you could put in the gradient as a decimal or a fraction. It doesn't really matter, but I can just write the equation as y equal to mx plus c. Make sure you replace the m with the gradient, which is 3/2, and the y-intercept is just 1. So there we go, we just got an equation for this. Okay, this one I really will say that it is better for you to just simply work out the equation. Now of course you could have just put in these 2 coordinates onto linear regression, and that should also give you the equation of the line, but you have to identify the coordinates first if you're going to use linear regression. Okay, but I always think that sometimes we should not be too reliant on the calculator. We should try to make sure that we know the basic concepts as well. Okay, and the calculator should be just like an added layer of check for you to be able to to ensure that you're doing it all correctly, right? And finally, question 4, which is about parallel and perpendicular lines. Okay, now I want to show you something first on GeoGebra, because this concept may not resonate very well with you. It may have been taught to you, but it's somehow, for some reasons or so, it's not very intuitive. So you may not remember the concepts or retain any of this in your earlier days. Okay, so I'll just show you a quick demonstration on GeoGebra, and you tell me exactly if you see a pattern here. Okay, now let me just type in an equation here. Let me just have a line here. Okay, I'm going to have y equal to, let's say, 3x plus 2. Okay, I got a line here. Now what I'll do is I'll create another line, okay, and you tell me what relationship you see between these two lines here. Now I'm going to put y. Oh, I tell you what, let's do something a little different. Let's just delete this first. Let's maybe use one of the tools, GeoGebra. Okay, I'm going to construct a perpendicular line to this line. Oops. Perpendicular line to this point. Okay. Okay. Let me see if I can rearrange this equation so that it looks better as well. I don't need this point. Okay. Doesn't really give me like the nicest equation, but I tell you what, I'll show you something else, because I was hoping that GeoGebra can create the equation of the perpendicular line in the gradient intercept form, but it does not really show it, but that's fine. What I can also do is I would do it another way. I'll do y equal to, let's say, negative 1 divided by 3, and I'll put an x here, and I'll just maybe choose a random y-intercept, let's say plus 6. Okay, there we go. Now, what do you realize about these two lines? Does it look like a perpendicular line? Does it create like a right angle? It seems like it, isn't it? Okay, but of course, if we want to be sure about this, we can always calculate the angle between these two lines. I'm just going to click on this line. I'm going to click on this line. It says 270 because it gives you like the obtuse angle, but we know that the acute angle between the two lines is just going to be 90 degrees. Okay, now, so I'm just going to remove this, but you get the point. Okay, now, having said this, we know that these two lines are perpendicular. So we know that the original line gradient was 3, and the gradient of the perpendicular line is -1/3. Now, I'm not sure if you realize there is actually a pattern here. Okay, now if you don't believe me, what I'll do is I'll just take off these two lines and I'll put in another equation for you to see. So let's say y equal to 5x plus 2. Then I'll do another equation here. So let's say I'm going to do y equal to -1/5, and I'll put x, and I'll put plus 5 here. Okay, and I'll press enter. Remove this line. again, you realize that these two lines looks perpendicular as well. But if you look at the gradient, which was 5, and the gradient of the perpendicular line is -1/5, I think one pattern you probably would have observed is that the gradient always have different signs, which means that when one is positive, the other one would be negative. And you realize that when one of the gradients is a number, the other gradient literally have the same number, but it becomes like a fraction. So it started off with 5, and now it becomes 1/5. So I would show you how to basically put all this into this. Now, so we agree that perpendicular lines, when it comes to the gradient, is that if you have this line and you want to find the equation of the perpendicular line, now the gradient is 3. Now, when it comes to the perpendicular line, now we do know that if one is positive, the gradient of the perpendicular line would be a negative number. But since 3 can be written as 3/1, we could do what we call the reciprocal of the fraction, which means we invert the numbers where the numerator goes into the denominator and the denominator goes into the numerator, so it becomes -1/3. So this would be the gradient of the perpendicular line, which is -1/3. Okay? Similarly, I will show you if you have -3 as the gradient. Now -3 can be written as -3/1. But for the perpendicular line, what you would do is, again, you will swap the fraction, which means you do the reciprocal. It becomes 1/3, because if this is a negative, this has to be a positive gradient as well. So now, if we want to identify which two lines are perpendicular, okay, now let me just erase. We could find that B and D would obviously be perpendicular, because -3, like we just said, the perpendicular line gradient will be just 1/3. So obviously this works very well. Yeah, and that's really it for perpendicular lines. Now, what about parallel lines? Now, parallel lines, I think, is probably the most straightforward. If you're gonna have two lines, which are parallel, which means the the gradients have to be the same. Okay, and basically we know that we can see that A and E are basically parallel. Okay, because they literally have the same gradient, which is 3 and 3 here. Okay, so that's really it for parallel and perpendicular lines for this one. Okay, now, so having said this, let's go down to the next part, which I want to spend a bit of time, which is looking at midpoint, the length of the line, and just to kind of review this again. Okay, again, this has been something that's been done in the last few years, but I thought it would be a good time to spend a little time on this. Okay, now, so if we want to find AB and we want to find the coordinates of the midpoint, now midpoint is obviously the middle between 2 points on the line. Okay, now if you have A, and if you write the coordinates for this, if you have this to be -2, and this will be 4, and B, when you read off the coordinates, again, read off the X first before the Y, so this becomes 4, 2. Okay, now to find the midpoint, okay, which is the point in between the 2 points. Now again, just by looking at this visually, you know that this point is obviously the midpoint. But sometimes when the points are not very clear on the graph, we want to be sure that we are capable of finding the midpoint using a more algebraic way. Okay, now, so to find the midpoint, what we always do is we add up both the x coordinates, which is basically finding the average between 2 points. Okay, so this formula is given to you in the formula booklet, so there is absolutely no need for you to memorize it. But remember, just have this understanding is that if you want to find the middle between 2 points, what you're trying to do is you're basically finding the average between the 2 points. So finding the average means you add up the two points. In this case would be the x coordinates and the y coordinates, and you divide that by 2. Okay, so I'll just show you really quickly. I can do -2 plus 4 over 2. Then I'll do 4 plus 2 divided by 2. Okay, so that should give me simply 1 and 3. And this relates very well of the coordinates on the point in this line. Okay, so that gives me the midpoint. Okay, so this should be quite clear, right? Hopefully this rings a bell. Now let's talk about the length of the line. Okay, we want to find out how long this line is. Okay, now the same thing that we could do here as well. The length of the line is actually very interesting. There's obviously a formula to it, but to be honest, I don't really think you need a formula for this particular question as well. Now what we'll do is I'm just going to use a different color to show you. Now if we want to find the length of this line, which is AB, what you could do is that if you draw this little dash line that goes vertically and another dash line that goes horizontally. Now, do you realize that this actually creates a right angle triangle? Now, if we could find what is the length of the vertical line and the length of the horizontal line, then we could use something what we call the Pythagoras theorem to help us find the length of AB, because we know that in the right angle triangle, if this is A, this is B, and C, we know that the Pythagoras works as a squared plus b squared equal to c squared. Again, a very popular formula. You have seen this a long time ago. So I'm going to use the same concept here. Okay, now we do know that the length of this line, which is from 4 to 3, oh sorry, 4 to no, I think I should, at this point this should be 4 to, okay, let me just erase this. I don't need the midpoint anymore. Okay, so we do know that this vertical distance is actually going to be 2. Okay, because we look at 4 and we look at 2, so the distance or the difference between the two y coordinates is actually 2, and the length of this line is obviously from -2 to 4. And of course, if you can just count, it would be just simply 6. Okay, so if we want to find the distance of the line or the length of the line, we could just put 2 square. Okay, I'm sorry, I'm going to use a different color, so it'll be 2 square plus 6 square equal to c square. Remember, c is basically what I want to find, so I'm going to do 4 plus 36 equal to c square, 40 equal to c square. So c would just be square root of 40. That's basically the length of the line. Okay, so this line is actually going to be square root 40. Okay, all right, and that basically gives you the length of the line using the Pythagoras theorem. Now, of course, in the formula booklet, you will see the formula that looks something like this, which is x1 minus x2 square plus y1 minus y2 square. You could use this formula as well. All you need to do is just put the numbers into the formula when you have the coordinates of 2 points. Okay, just make sure you label them as x1, y1, and the other point to be x2, y2. And technically you should get the same answer as well, because this basically uses the Pythagoras theorem. It's just that they came up with the formula so that you don't necessarily have to draw a graph before you find the length of a line. Alright, hopefully that makes sense. Now I'm not going to do part C, which is the gradient, because we just talked about this in the earlier part, so you should know how to find the gradient when you're given 2 points just by simply using the formula. Okay, alright, just a couple of things left before to wrap up straight line graphs. It says, does the point 3, 7 lie on the line? Okay, what this question is basically asking is that, okay, let me just draw this for you just to see if this makes sense. So let's say you've got a line here. And we know that 12x minus 25 will look maybe something like that. So let's say if this is negative 25, because the gradient is positive, so that we know that the graph is going to go in this direction. The question is asking, if you have 3, 7, does this point lie on the line? Now then, how do we even know that a point actually lies on the line? Of course, you can try to put this equation onto your GDC, which I'll show you how this works. Another way to do it is that what you could do is that you could put these two numbers into this equation here, because we know that this is the x and this belongs to the y. And if we put the numbers into the equation, it will look something like this. I'm going to get 7, because y is 7, equal to 12, multiply by 3, subtract 25. Your job is to identify whether the left side looks the same as the right side. If they look the same, that's great. That means the point is basically on the line. But if they don't look the same, then it just simply means that the point is just simply not on the line. So let's just work out the right hand side. You're going to get 36 minus 35. So you're going to get something like 7 equal to 11. This obviously doesn't make any sense. So that means that this point is not going to be on the line. Not on line. Okay, now another way to do this is that if you use the GDC, okay, again I'll show you with the GDC again. We're going to plot the equation. So you're going to have the equation was 12x minus 25. So let's clear this. 12x minus 25. Okay, now I'm going to graph it. Now, so if you want to find out whether this point basically lies on the line, what you could do is you could go to second trace. I want you to put the value, click on value. I want you to put the value, which is the x coordinate, which happens to be 3. Then I'll press enter. Do you see what the value of y is? It's 11, right? But the question was asking for the y to be 7. So we know that in this case that 3, the original point of 3, 7 does not lie on the line, because when x is 3, y is meant to be 7, not 11. Okay, 7, 11. You see the point, right? Okay, so yeah, that's the point. You could obviously use the GDC to help you solve question 6. Okay, the next part is we're going to look at intersection between two lines. Now, again, if you have a graph and you have 2 points here, what the question is basically is, can you find out what is this point and what is this point here? What I would suggest with this is that you should be using the calculator. If you use an algebraic way to do it, then you have to solve simultaneous equation, which could be some trouble for you if you do the AI course, okay? And chances of you making mistakes will be very, very high. So what I'll do is I'm going to show you again how we can put this onto the GDC. Okay, so if we go onto the calculator, all right, then we're going to clear this. I'll put, okay, now the only downside to this is that when you put these two equations here, it starts off by saying what is y, but the equation here that is given to you is 5x plus y equal to 17. So we may have to rearrange this equation. There's actually another way to do it on the GDC if you want to find the intersection of the line, but I'll show you 2 ways. Okay, one way is that you could rearrange this equation so that it looks something like this, which is y equal to negative 5x plus 17. All right, which is great, right? But the next one, which is 8x minus 2y equal to 2. Now this might become a problem for some of you. So what you could do is you could bring the negative 2y to the other side of the equation. So it will look something like this. So it will look like 8x equal to 2 plus 2y. Because if this is negative, then you want to make sure you add it so that it's eliminated from the left side of the equation. Then what I'll do is I'll bring this 2 and it's going to join 8x. So it's going to look like 8x subtract 2 equal to 2y. But remember, what we really want is just simply y itself. So I'm just going to divide 2 throughout the equation. So you're going to get 4x minus 1 because you're going to divide this by 2 and divide this by 2. Now this is a lot of work, okay, because if you want to use just simply putting these two equations onto the graphs, then this might become a bit of a problem, okay. But I think it's still worthwhile to go through because I think it's just very basic algebra that most of you should be able to cope with this as well. So if you decide to use the feature on the stat plot where you could plot both equations and hopefully to allow you to be able to find the intersection between the 2 points, that's where you need to rearrange the equation. But I do think there could be another way to do it, but it may not again be very intuitive. But I just don't have this feature on my calculator for now. So this, I would say, I think using the stat plot might just work very well, at least for now. But I think if you use the feature on your calculator, which is the Polysmith, if you go to apps, go to Polysmith, you may be able to find that feature and put those equations on it, okay. So I'll leave that on to another video again, but I'm just going to show you with stat plot that we can actually also do the same, produce the same result as well. So if you have 4x minus 1 and minus 5x plus 17, so I'm just going to do a quick review on this one. So it'll be negative 5x plus 17. Then we have the other equation that should look like 4x minus 1. Okay, then you're going to graph it. Okay, so you should see the intersection point. Then I'm going to go to second trace, go to option 5. Again, they're going to ask for the left bound. Just choose somewhere to the left of the intersection point, press enter. Right bound to the right of the intersection point, press enter. So you should get x to be, if you look at the intersection, you're going to get x to be 2, y to be 7. Okay, so that should really solve the question here. So the intersection point would just be 2, 7. Okay, so again, use the GDC for this one. Alright, finally, to find the gradient of the line given a very complex equation like this, of course, for this question, you may have to rearrange the equation first before you put that onto the GDC to find the gradient, okay. So what I'll do is, because it is a fraction, okay, and it's not really possible to put this onto your GDC with a fraction like that, so what I'll suggest is that we will try to modify this equation first, or manipulate this equation. So what I'll do is I'm going to multiply this by y, multiply this by y first. Reason for that is to remove the fraction, so it's going to look something like this. Okay, so just by doing this step, it removes the fractions, which is awesome. Now what I could also do is that I could just now if this is 3y and I just simply want y, what I could do is I'm just going to take this equation and I'm going to divide this by 3. Okay, now having said this, I will show you the algebraic way of doing this first. Now of course, if we simplify this, you're going to get something like 6 minus 10x divided by 3 gives me y. Now again, since I'm looking at y equal to mx plus c and I'm looking at the gradient, okay, so what I can do is I'm going to split up this fraction and it's going to look something like this. It's going to be 6 over 3 minus 10 over 3x. Okay, and do you realize something here? This actually looks like mx plus c. I'm just going to rearrange this so that it looks exactly the way I want it to be. So it's going to look something like that. Plus 6 over 3. Do you realize this is actually the gradient, which is negative 10 over 3. So yeah, I mean, you still need some basic form of algebra. Sometimes we're given more complex equations, but I think it's still very doable. I think it's always a good mix of using the calculator and just manipulating with the basic form of algebra. Okay, that's going to help you with that. Now, so hopefully, let me just do a quick summary. of straight line graphs again. Now, so when we have y equal to mx plus c, this is what we call the gradient intercept form. Okay, and we do know that m is simply the gradient. And again, we know that the formula for gradient is just y2 minus y1 over x2 minus x1, and usually we call the gradient to be m, while c is just the y-intercept. Again, the y-intercept is basically where the graph cuts the y-axis. This is what we call the y-intercept. Okay, so this is something that we should know at the back of our heads. This is basically the most popular equation that we use for straight line graphs. Now, sometimes you might get to see something like this, which is really awkward, isn't it? But what really this does is that it is the same form. Okay, this is actually what we call the standard form of a line. Okay, but why does it look so complicated? Now, I'm just going to take one equation here. Let's say y equal to 3x plus 5. What this does is that it brings all the variables, which is or the terms, I would say, 3x and 5, what they did was kind of goes into the left side of the equation. So what this does is that if I subtract 3x, so it goes onto the left side, and I subtract 5, this actually becomes equal to 0. These two are basically the same equation. Where you have the standard form, basically what it does is that you have the x, the y, and the constant, which is just the number itself, going on one side of the equation, while the right side of the equation is just going to be 0. So it's just another way of writing a straight line graph. Okay, this is only being used only if the question wants it to be written in the standard form. Otherwise, you should always be using y equal to mx plus c. Does that make sense? Okay, so but just something to take note of. If you see that you have to write an equation in this form, it's nothing spectacular. It's just a different way of writing a straight line graph. And finally, this one is not essential. Okay, this is actually what we call the point gradient form, or the point slope form. Okay, if you are more familiar with the American curriculum where they use slope more than the gradient, this is not essential. Okay, sometimes it might create more complications, but if you've seen this before and you would like to use this, it is fine. Okay, but I'll just show you with an example that we could use this. Now again, like I said, this is not essential. You could just go ahead and use y equal to mx plus c, and it will give you the answer. But I'll show you that even with the point gradient form, it could also find you the equation of the line. So let me give you an example here. Now, so let's say if I have 2, 3, and I have 3, 5 in this case. Okay, so I got 2 points. So if I want to find the gradient, we do the same thing again: x1, y1, x2, y2. So if I use the formula, I'm gonna get 5 minus 3, 3 minus 2. So that should give me 2 over 1. So the gradient is 2, right? Now what this formula does is that you don't need to find the y-intercept. What you could do is you could just use this formula, which is the point gradient form. I wouldn't call it a formula, it's just a different representation of the line. What you could do is you just substitute the numbers from these points here. Now I'm just going to keep y as y. y1 was written as to be 3. Now we know the gradient was 2, and I'll keep x as x, and I'll just replace x1 with 2. Do you realize something? That what I need to do is I just need to simplify this equation here. Okay, and if I bring this 3 by adding 3 to it, I'm just going to get 2x minus 4 plus 3. So it will give you y to be 2x minus 1. So this step, what it does is that it bypasses the step of finding the y-intercept if you simplify the equation. Okay, but like I said, this is not an essential equation that you need to know. If you have learned it before and you're confident with this, go ahead and use it. If you don't, there is no you're not going to lose any sleep over this, okay? Because the question is not going to ask you to write the equation in the point gradient form. But I do think that it's something that can be very useful. At least you have seen it before, so you know how this works as well. Okay. All right. So yeah, basically I'm just maybe gonna go through a couple of questions here. If you think that this is gonna be helpful, just keep watching this video. Otherwise, I think I'm pretty good with the review of the basic straight line graph that you expected to know. Okay, so I'm just going to finish up this video with these two questions, just to review what we've done. Okay, a line has gradient m equal to half, passes through the point 48, write the equation in the form of y equal to mx plus c. So this is the gradient intercept form. Okay, so to write the equation, we can just obviously, it gives you the gradient, so it saves us the trouble. So you're going to have y equal to half x plus c. Okay, but because we always need to find c, this is where you make use of this 2 points here, which is the x and the y value. So I'm going to substitute these numbers into the equation. So you're going to get something like 8 equal to half times 4 plus c. Okay, so this will give me 2 plus c, so c would just be 8 minus 2, that gives me 6. So the equation is just going to be half x plus 6. Okay, and the next one, now this one is interesting. It says find the equation in the gradient point form. Okay, or the point gradient form. Okay, like I just mentioned earlier. So I'll show you how this works. Okay, so the formula we have here is y minus y1 equal to m bracket x minus x1. Now since the question wants it in the gradient point form, then all we need to do is just substitute these numbers into this formula. So in this case, this will be like your x1, this will be like your y1. Okay, so y minus 2 equal to the gradient x minus minus 1. Okay, so if I simplify this, it's gonna look like, because 2 minus gives me a plus, you could just leave your answer like that because the question wants it in the gradient point form. Okay, so this would be good enough as the answer. If you simplify, you're going to end up grading like the gradient intercept form, which is not what the question really wants. So you could just leave the answer like that if it asks for the gradient point form. Okay, all right, so this is pretty much it for the video. Hope you like this. Make sure you subscribe as always. All right, I'll see you very soon, and goodbye.